Alright, welcome to this coding interview walkthrough. So today we will tackle the classic activity selection problem, right? So here you are given two arrays, start and finish, right? Representing the start and end times of various activities, right? And our goal is to basically maximize the number of activities that we can do in a given day, right? But remember, you can only perform one activity at a time, right? So for example, if we are given these two arrays as the start and the finish array, right, representing the start and the end time of each of the respective activity, right, the optimal solution over here would be 4. That is, we can do maximum 4 activities in a given day, right? And how did we arrive at 4? We essentially found the non-overlapping activities that we can actually do, we can actually sequence in a given day, right? So for example, if you see over here the first activity, now since it is the first activity, we can actually consider it, right? So it will start at 1 and end at 2. That's what we are saying, right? Now when we move to the second one, it is starting at 3, which is actually later than the end time of the finish time of the first activity, right? So actually this is not overlapping and I can actually consider the second activity also, right? So it is starting at 3 and ending at 4, right? Now when I move to the third activity, it is starting at 0, right? And since its start time is actually lesser than the end time of the previous activity, this will be overlapping and I cannot consider it, right? And so I will just ignore it and then move to the next one. Now the next activity is starting at 5, right? And the start time of this activity, if you see 5, is actually lesser than the end time of the, greater than the end time of the previous activity, right? Which was 4 over here. The previous selected activity, I mean, right? And hence this is a non-overlapping activity and I can consider this. Now moving to the next activity, it is starting at 8 and again the start time of this activity is actually greater than the end time of the previous activity, right? So I can consider this one as well and increase my count, right? And then moving to the next activity, it is starting at 5, right? And this start time is actually lesser than the end time of the previous considered activity, which was ending at 9. So again, this is overlapping and I cannot consider it, right? So in total, I was able to consider 4 activities which were non-overlapping and hence my expected output is 4 over here, right? So that's what we are doing over here. So that's the entire problem statement. Now maybe you can just pause this video and try to think of a solution. And once you are done, you can just come back and check the solution here. Okay, so in this problem, we need to maximize the number of activities. And so this is an optimization problem, right? And in such optimization problems where we are required to basically minimize or maximize the result, we can actually use greedy algorithm, right? And in general, we can actually talk about the greedy algorithm template that can be applied to any problem which can be solved using greedy algorithm, right? So if I show you the pseudocode, this is a generic template that we can follow for any problem wherever the greedy algorithm can be applied, right? In general, right? So any problem which you feel is an optimization problem which can be solved using greedy algorithms can actually be fit into this particular template for its solution, right? So what we do is, first of all, we have a result value that we basically need to maximize or minimize, right? Now I'm talking in general, not specific to this problem. We have a result which we need to maximize or minimize, right? Which we can initialize over here to 0, right? And now we run a while loop till we have looped over all the items in the input array, right? Over here, we have to basically consider all the items, right? So we can just consider that we are using a while loop over here and we will run this while loop till we have looped over all the items, right? And now in every iteration, we have a selection criteria, right? For selecting one of the items from the list, and then we will do a feasibility check over that particular current item which is selected, right? And this selection criteria can be anything, which depends on the problem. Based on the requirements of the problem, you will be having a selection criteria on which you will be selecting a current item, right? And then you will be doing a feasible check, which will also be specific to that problem, right? And based on if that particular current item is actually feasible or not, we will be adding it to our result or we will be ignoring it, right? And finally, we will be just returning the optimized result this way, right? So that's the generic template that we have to follow when we are applying greedy algorithm to any suitable problem, right? Now over here, if you see in this particular problem, the result value that we are trying to optimize is the count of non-overlapping activities. right? So we can just maintain a count variable over here to track that, right? And initially the count will be 0, right? Now what we can do is we can actually loop over all the activities, and in each iteration we will be selecting the activity with minimum end time from all the activities that are remaining, right? That are yet to be considered. So this will be our selection criteria basically for choosing an activity, right? And for this purpose, we can actually just sort these activities by their finish times, right? And then just loop over this sorted array to always get the activity with the earliest end time from the available ones, right? So that will basically suffice our selection criteria, right? Now we need to check if the selected activity is feasible or not as per the problem statement, right? And here our criteria for defining that would be to check if the selected activity does not overlap with the previous activity, right? And so we can count this activity only if the start time of this activity, which we are checking right now, is actually greater than the end time of the last selected activity, right? And if it is feasible, then we can just increment our count by 1, right? And if not, we can just ignore it, right? And also if we are finding that particular current activity is feasible, if it can be considered, then we will be comparing the end time of this particular activity now with the start time of the next activity that we are going to consider, right? So for that purpose, maybe we can also maintain another end time variable over here, which will track the last end time of the latest activity that we have considered, right? So that's what we can do. And this way, after considering every activity, we will have the count of the maximum non-overlapping activities in our count variable, which we can just return as the output, right? So now maybe let's break down this approach a bit, right? So first, what we will be doing is we will be pairing every activity with its start and the finish time, right? Because right now we have two different arrays which track the start and the finish time of each activity. So we will be creating a new array first of all, and we will pair the start and the finish time of, every activity, right? And now we will sort this particular array, right, by their finish time, right? And now we will just go through them one by one, right? And we will check if an activity starts after the last selected one finishes, we will select it. And if not, we will just ignore it. And we will keep doing this to pick as many non-overlapping activities as possible, right? Now maybe let's walk through an example visually, right, for better clarity. So this is the example that we were seeing, right? So first of all, the first activity is 1, 2. Now, since this is the first activity itself, right, we are just going to pick it. And if you see, we have already sorted this particular, activities array by their finish times, right? This is already sorted, right? We are getting 2, 4, 6, 7, 9, and 9, right? So this is a sorted activity array, right, by their finish time. Now the first activity is 1 and 2, which I'm going to just select as is. Now the second activity, if you see, is starting at 3, and this start time of this is actually greater than the end time of the previous activity, right? So I can select this one as well since it is non-overlapping, right? Now moving to the next activity, the start time is 0, which is actually lesser than the end time of the previously selected activity, which was 4, right? So I need to just ignore this one because this is overlapping, right? So I won't consider this. Now moving to the next one, again, the start time of this activity 5 is actually greater than the end time of the last selected activity. So I will select this one as well, right? Now moving to the next one, again, the start time of this activity is greater than the end time of the last selected one. I have selected it for that reason, right? Now moving to the next one, I will have to skip this particular activity since the start time of this activity is actually lesser than the end time of the previous selected activity, right? So in total, I was able to select 4 non-overlapping activities which I can do in a given day, right? And so my output will be 4 over here, right? So that's the entire solution for this particular problem using the greedy algorithm. I hope you understood it well. Now talking about the time and the space complexities, since we are first sorting the array, it will take order of n log n time, right? And then we are just looping over every element of this array, which would be another order of n, right? And since order of n log n is obviously greater than order of n, the overall time complexity over here will be order of n log n itself, right? And talking about the space complexity, since we are creating another array for start and finish time pairs for each of the activity, the space complexity will also be order of n over here, right? I mean, the space complexity will be order of n and the time complexity will be order of n log n, right? So that's the entire solution. Now maybe let's code this. So I will just first of all declare a function and call it as activity selection, maybe like this, right? And this will accept the start array and the finish array, right? Like this. Now what I will do is I will just capture the length of, the total activities over here in a variable n, right? Like this. And now what I will do is I will just create a pair array for the start and the finish time of every activity, right? And for that I can use a list comprehension. Maybe I will say for I in range n, like this, I will just be selecting the start of I, like this, and the finish of I, like this, right? So that's what I will be doing, right, to create this particular array. And now I will just sort this particular array like this, where my key will basically be the finish time for every array, for every activity, right? Like this. And the finish time will be given by the second element, which will be at index 1. So I will be selecting it like that, right? And then I will be just declaring and initializing my count variable to 0. And also I will just declare and initialize the end time to 0, right? Which I will just keep updating as and when I'm selecting new activities, right? So that's what I'm doing over here. Now I will just loop through this particular sorted array. So again, I will say for I in range n, right? Because there are n activities. Now I will check if, the start time of the current activity is actually greater than the end time of the last activity, and that end time of the last activity would actually be present in this end variable, right? If that's the case, then I will just increment my count variable by 1 because I'm considering this activity now, and I will now update the end time with the end time of the current activity, like this, right? Like this, right? And finally, once I'm done looping over every activity in this particular array, I will be just returning the final count, which will have the maximum number of non-overlapping activities that I can do in a given day, right? So that's the simple and neat solution for this particular problem. I hope you understood it well. And this is using greedy algorithm. I hope you understood the crux of the greedy algorithm as well. It's a very important and very useful technique to solve any optimization problem. So whenever you have, things like maximizing or minimizing in any problem, you can actually try to fit it into a greedy algorithm, try to think it from the greedy algorithm lens, right? And if at all you feel that, yes, it can be fit into a greedy algorithm approach, then, it has a standard template, right? And essentially you have to check whether it can fit into a greedy algorithm or not by actually trying to fit it into that template, right, that we discussed. All right, so that's it. And now I will see you in the next video. Thank you.